Let's talk about libraries. There are two types of libraries in Solidity. They are similar to contracts and you can define functions in them. You can have them either with only internal functions or with public functions. If you declare them with public functions, then they become their own contract on the blockchain, and you can reuse the functionality, but this is the lesser common way to use them, and we won't be going into the details of this here. It's quite common to declare libraries with only internal functions though. If you do that, then all the functions become part of the contract you are using the library in. So it's just a way to make the code more readable. To declare a library, just use the library keyword instead of contract. And now you can define functions in the library. But unlike the contract, you cannot have any state in the libraries, only functions. So here we declare only internal functions. So they will eventually just become internal functions of any contract where we use the library. So then to use the library, we just call the library name dot function name. Simple and easy. So here we can just say math.min or math.max, and otherwise use it like they are internal functions. And there's also a shortcut for using library functions. If we say using library name for and then type, so here using math for uint 256, then we can call the library functions on the given type. Of course, the type here has to match what the library functions are actually using as a type. And you can use any type. It doesn't have to be only uint 256, of course. So here, this is now much more readable. Basically, you divide the number x with the ceiling by y. And usually in Solidity, you just divide two numbers, then it will be rounded down to the next full number. Because remember, we don't have fixed point numbers in Solidity, so it must be rounded either down or up. But if you wanted to always round up, then you could do this with this function here and use it in a nice way where you just put it in a math library and then using math for the number type, and then you can just write x style def y.